Okay, this is section 1.1a, Pre-Calc Review 1, Math 1510. So a few concepts that are reviewed here from pre-calculus are as follows. The first one is the real number line. In this class, we'll be using the real number line to express our answers, especially later on in chapter 4. Let's start off with the number line with 0 here and some positive integers on the right of 0 and some negative integers on the left. And of course the real number line is very dense. There's all kinds of numbers between 0 and 1, like half and like pi, square root of 2, etc., etc. So one of the ways we express our answers in the future when we'll talk about functions being increasing and decreasing is using the interval notation. Now the interval notation consists of parentheses or brackets. So if you write bracket a comma b, what this means is you're starting at a, stopping at b, and it includes all the numbers between a and b. Okay, so if you have something like 0 to 4, it would indicate all the numbers from 0 to 4, and you put solid dots at 0 and 4 because it includes 0 and 4. Okay, so it's all reals between and including 0 and 4. If you don't include the endpoints, you use parentheses. Okay, so this would be like, you put 0, 4, like so. This would mean all real numbers between 0 and 4, but not including 0 and 4. You could also have half open intervals, so you could have one end open, one end closed. Okay, so going back to this is a closed interval, this is an open interval. Whereas this third one is half open or half closed, depending on how you think about it. Half open or half closed. So this means that, let's say for example you have 0, 4, you're excluding 0, but you're including 4. If you were to draw this on a number line, you'd have 0, 1, 2, 3, 4. You would have a solid dot here, whereas an open dot there, and you would shade everything in between. Alright, so the half open, half closed could happen on either end. You also have infinite intervals, which, as it indicates, goes on. So you could have an interval going from a point A to infinity. So let's say you start here, if this is A, positive infinity is on that end. Or you could have, let's say a finite number like 2 infinity. So you'd start at, if this is 0, this is 2, solid dot, and it goes on. You could have this part to be open, both ends open, but note that wherever the infinity value is, it'll always be an open interval, because infinity is not a real number. It's just to say that it goes on forever. You could also have an infinite interval from another direction, and so this would be negative infinity comma negative 2. If this is 0, negative 2 is here, closed dot, because we're including that, and it's all the numbers to the left. Okay, you could also have the entire number line, that would be negative to positive infinity. Note that they're all open intervals because it's infinite. Okay, so that would be the entire number line. Alright, now the next part of this section deals with exponents and radicals. So that's the second part of this section, exponents and radicals. So as you have learned in pre-calc, exponents are a shortcut to write repeated multiplication. So if you have b raised to n, it means it's b times b times b, etc. And that's n copies. Of course, if you have b raised to 0, you might recall that that is 1. You may also recall that radicals can be thought of as an exponent. So for example, the square root of b is the same as b raised to, hopefully you remember this, that's 1/2. If you have cube root of b, it's b to the 1/3. If you have cube root of b squared, that would be b raised to 2/3. This 2 divided by 3. So in general, if you have nth root of b raised to m, it's b to this m divided by n. So a lot of this is explained in more detail in your textbook. So if I can, I don't know if I can get the book to show up, there's a bit of a glare, but it will be on page 5 in your textbook. Alright, so properties of exponents, you've seen that in algebra as well. Also negative exponents are important, they show up a lot in this class. If you have b to the negative n, it's 1 over b raised to n. The properties of exponents that I mentioned earlier are as follows. So here's a list. If you have b to the n times b to the m, you add the exponents. Again, I'm not deriving all these, they are derived in basic algebra books. If you have b raised to n divided by b raised to m, you subtract n minus m, b raised to n minus m. Also, if you have the power of a power, b raised to n raised to m, then you multiply. And these properties are all explained with examples on page 6 in your textbook. You also have the product property. If you have a times b raised to n, if you have a multiplication, then it's a raised to n times b raised to n. And finally, if you have a division, a divided by b raised to n, that's a to the n over b to the n. A big word of caution that this property right here is abused when you have addition. So you have a plus b raised to n. It is not equal to a to the n plus b to the n. Instead, what you would do is, if you have a plus b to the second power, you would write that as a plus b times a plus b, and then you would multiply it out, as we call it, as FOIL. So a squared plus ab plus another ab or ba plus b squared, and so on. This will be reviewed in the next unit, the second part of this section. So for now, I'm going to go over a worksheet, and this will correspond with the homework on WebAssign for section 1.1a. So the first question says to evaluate the following: simplify your answer fully, unsimplified or decimal answers are incorrect. So you could technically use a graphing calculator to figure this out, but when you don't have numbers, you'll need to know how to do this by hand. So we're going to do it both ways, first by hand and then on a calculator. So if you have a negative exponent, this is 27 raised to negative 2/3, so you can write that as 1 divided by 27 to the positive 2/3. And then we saw that this 3 means it's a cube root. This is a cube root of 27, the whole thing squared. So that's 1 over cube root of 27 is 3. So it's 3 squared, which is 1 over 9. Okay, calculator check. You would type this in carefully using parentheses. 27 raised to parentheses negative 2/3, and you get a decimal answer. Remember, no decimal answers, so we'll go to math, frac, convert it to fraction, and you have 1/9. Moving on, for this problem, I'm going to multiply these two exponents using that power of a power rule. So negative 2 times 3 is negative 6. And then, since it's a negative exponent, I'm going to flip this fraction and write that as 5 over negative 1 raised to positive 6. So that becomes 5 raised to 6 over negative 1 raised to 6. This, being an even power, it's just 1, so it's just 5 raised to 6 over 1. So 5 times 5 times 5 times 5, 6 times, is going to be 15,625. Once again, this can be checked on the calculator. parentheses, parentheses, negative 1 over 5, double parentheses there, and then you have close that parentheses, raise to negative 2, close the final parentheses, and raise it to the third power. And I think I have, oh, I guess I closed 2 parentheses too soon. There we go, and that's the answer. Alright, next question. This is in radical form. We can convert this to exponent form by using that rule that if you have the nth root of x raised to m, it's x raised to m divided by n. It's this divided by this. This is an n. So this would be 6 divided by 3. Okay, this divided by this, so that's 5 squared, which is 25. On your calculator, under math, cube root is right here, or you can use this option. Right now, let's use the fourth option. Cube root of 5 raised to 6, close it up, 25, it checks. And finally, this messy looking question. I would say that cleaning up within the parentheses first would be a good idea. So on the top, since these two are multiplied, we add the powers. Negative 3 plus 5. Negative 3 plus 5 is 2, so that's 4 squared over 4 to the negative 2 raised to negative half. Since this is a division, we would subtract the exponents, so it's 4 to the 2 minus negative 2. Go off to the side. 2 minus negative 2 is 2 plus 2, which is 4. So it's 4 raised to 4 to the negative half. These two, it's a power of a power, so we're going to multiply. So it's 4 raised to 4 times negative half. When you calculate that, 2 goes into 4 2 times, so it's 4 to the negative 2, which is 1 over 4 squared, which is 1/16. This can also be checked on the calculator. Let's see, so parentheses first, 4 raised to negative 3 times 4 to the 5. And then it's divided by 4 to the negative 2. Close the parentheses, raised to parentheses negative 1 over 2. And you get a fraction, convert it to, get a decimal, excuse me, convert it to fraction, it's 1/16, which is what we got there. Alright, last question on this page. Question says, rewrite the expression using positive exponents only. So I'm going to write this first. If you have square root of a, it's a to the 1/2. Okay, this is the 1 divided by the 2. But here I have negative 3, so it's x to the negative 3 divided by 2. Now, this is a product. We can break it up as a square root of 9, which is 3. I'll do that in the next step. And then here I have x to the negative 5 divided by 2. So as I said earlier, this is 3. I'm going to float it to the front. Now the bases here are the same, so I can add the powers. So it's x to the negative 3 halves plus negative 5 halves, which is negative 8 halves, which is negative 4. So it's x to the negative 4. And that gets rewritten as 3 over x to the 4th. Because it's a negative exponent, it goes down to the bottom. The 3 stays up on top because it's got a positive 1 as its exponent. So did we answer the question? Rewrite the exponent using positive exponents only? Yes, we did. Alright, one more page for this homework. The next 4 questions are basically simplify the expressions. So we'll be using properties of exponents. This is 25 times x to the negative 2, so I can distribute that power using the product property. So it's negative half, x to the negative 2 raised to negative half. So the first piece, since it's a negative exponent, it's really a term in the bottom. It's 1 over 25 to the half, which is the same as the square root of 25. Here you multiply exponents, the 2's cancel, and a negative of a negative is positive, so it's just x raised to 1. So it's 1/5 x, or you can squish it together and write it as x over 5. Either of these will be fine. And WebAssign will take equivalent answers. Next question. This is multiplied and divides. We're using the exponent rules for both. This 3 gets distributed to all the powers. So it's x squared cubed, y cubed cubed, and z to the 4th cubed. So you get x to the 6th, y to the 9th divided by z to the 12th. And that's as far as you can go, because none of these letters match. Alright, next question. Now this is supposed to be an A. It looks like an alpha. What we have here is a to the n to the 5, which we can multiply exponents, and you get a to the 5 times n times 5 is 5 times n, divided by a to the 2 minus 3n. Now, since this is a division, we're going to subtract the exponents, so it's a to the 5n minus, in parentheses, the bottom power. Parentheses because there's two terms there. Now distribute the negative sign, so you have minus 2, and 2 negatives makes a positive 3n. So finally you have 5n plus 3n, which is 8n minus 2. And that's as far as you go. That's a little weird. This is also a little strange. The next question is you have cube root of x to the 3a plus b. So what you're going to do here is write it as x to the 3a plus b, and it's 1 divided by 3. It's this divided by that. Okay, that's how you convert from radicals to exponents. Now you can split this fraction up, since there's an addition here. Split that common denominator and you get x to the 3a over 3 plus b over 3. The 3's cancel, so you have x to the a plus b over 3. Alright, the last question here is something you learn in algebra as well. It's called rationalizing the denominator. It's when you have a radical in the bottom and you don't want it there. So the technique is to keep this equivalent, you multiply by 1. If you multiply by 1, you don't change its value. But what is this 1 going to look like? Well, it's going to be the square root of AB divided by the square root of AB, which is the same as 1. Now once you do that, you multiply the tops. It's 5 times square root of AB. The bottom, the square root of something times the square root of the same thing is the square root. So if you have square root of x times the square root of x, it's the square root of x squared, which technically is the absolute value of x. We're going to assume everything is positive here and just leave it as x. So in this case, it's just AB. Square root of AB times the square root of AB is just AB. And you do not have a radical in the bottom, so you have answered the question. The next question here, since you have the square root for the whole thing, you first want to split it up. And this is a property of exponents. If you have a division, you can break up the exponent. So there we are. And now we're going to multiply by 1 again. You don't want to have a square root in the bottom. So you multiply square root of y to the top and bottom. So the top, you can actually bring it all into 1. It's 5x times y, because they both matched. The radicals matched. You can multiply the two. The bottom, square root of y times square root of y, it's similar to this previous problem. It's the square root of y squared, which is just y.